Continuing with the final exam review for college algebra, we're under the heading one-to-one functions and their inverses. I'm on question number 3, which asks you to determine the inverse of the one-to-one function. So remember, this is a two-step process. And the first thing you have to remember is that f of x is the same thing as y in these problems. And the first step is to interchange the x and the y so that this problem is rewritten as x equals 4 times y minus 3 to the third minus 2. And then our goal is to solve that equation for y. So I'm going to begin the process of doing that. I'm going to add 2 to either side so that I have x plus 2 equals 4 times y minus 3 to the third power. I then need to undo the multiplication by 4, so I'm going to divide everything by 4 so that I have x plus 2 all divided by 4 equals y minus 3 to the third. I then need to undo the power to 3, so I'm going to take the cube root of both sides because the inverse of cube is cube root, so that I have the cube root of x plus 2 all divided by 4 equals y minus 3. And I'm almost home free. I then need to add 3 to either side so that I have 3 plus the cube root of x plus 2 all divided by 4, which would equal y. But remember, in this scenario, the y represents f inverse. So this is actually f inverse of x. Number 4 is, again, it says determine the inverse of the one-to-one function. Again, it's important to note that they're telling you this is a one-to-one function. That way we know the inverse actually exists. Also to remember that f of x and y here are the same thing. And again, we begin the process by interchanging x and y so that we rewrite the problem as x equals 2y, oh, excuse me, not 2y, 4y, minus 2 over 7 minus 2y. Now, I'm going to make this a little bit easier. I'm going to put the x over 1 so that I have basically a fraction equal to a fraction, and we're going to cross multiply. So we're going to have x times 7 minus 2y equals 1 times 4y minus 2. I'm going to go ahead and do that multiplication by distributing. So I have 7x minus 2xy equals 4y minus 2. And so then I notice I have some pieces that both of them have y's, and my goal is to ultimately solve for y. So I'm going to get all the y's together. So I'm going to add 2xy, add 2xy, so that I have 7x equals 4y plus 2xy minus 2. Again, I'm trying to solve for y, so I need to get it all by itself as much as possible. So I want to move the 2 to the other side. So I'm going to add 2, so that I have 7x plus 2 equals 4y plus 2xy. I then notice on the right hand side, I have a y in common. So I'm going to factor that out. So I have 7x plus 2 equals y, and I have 4 plus 2x remaining. And I'm almost home free. I need to do the division to divide out the 4 plus 2x. So I'm going to divide by 4 plus 2x on either side, and I end up with 7x plus 2 all divided by 4 plus 2x, and that equals y. But again, remember, in this scenario, y equals f inverse. So this is your answer. Okay, in a supplemental question, again, you're asked, determine the inverse of the one-to-one function, and they give you the function f of x equals x to the third plus 7. Again, notice they do tell us it's one-to-one, so we know an inverse exists, and f of x is the same thing as y. We begin by interchanging x and y, so we rewrite, we have x equals y to the third plus 7. Then we want to solve for y. So I'm going to subtract 7 from either side so I can isolate the y. So I have x minus 7 equals y to the third power. Then I want to undo the cubing, and again, to undo a cube, we take the cube root of each side so that I have the cube root of x minus 7 equals y. And again, in this case, remember that y, that result, is actually our f inverse. That's your answer. All right, the next part we get into on page 7 is quadratic functions. And the first question asks you to find the vertex of the function. And in the format that this one is in, the best thing to do is to use the vertex formula, which is one of the formulas included on the formula sheet and is listed at the beginning of the problem. If you'll remember to find the vertex is in the form h, comma k. H is the opposite of b over 2a, and you find k by substituting h back into the function. A, B, and there is a C. Remember, A is always the number in front of the squared term, B is the number in front of the linear term, and C is the constant. So in this case, I would have the opposite of negative 6 divided by 2 times 4. So that's positive 6 over 8. Negative and a negative make it positive. 2 times 4 is 8. 8 simplifies to 3/4. If you want to convert that to a decimal, it would be 0.75. We then take the value of 3/4 and we substitute it into the original problem. So we would have 4 times 3/4 squared minus 6 times 3/4 plus 9. Now, honestly, at that point, I'm probably going to pull out my calculator and do the calculations on the calculator. So I would type 4 parentheses 3 divide 4, close them, square it, minus 6 parentheses 3 divide 4, close them, add 9, and I'm going to hit enter. Now it does come up as a decimal. I can convert it back to a fraction by pressing math and choosing option 1, and it gives me 27/4. So H is, or K, excuse me, is 27/4. So the vertex which is typically written as an ordered pair, would be 3/4, comma, 27/4. Okay, then you're asked to find the quadratic function with a y-intercept at 7 and a vertex located at -3, 5. Okay, I'm not sure if I have enough time to cover this one, so I'm going to go ahead and stop this video, and we'll pick up at this point on the next video.